According to historians, this field of, or the branch of mathematics, that is geometry, it dates back or goes back to ancient history or ancient period of history. And the father of geometry is Euclid of Alexandria. And geometry has been taken from a word geometron, where geo means earth and metron means measurement. So it's basically the study of measurements, the size, the shapes of objects. Size, shape, measurement, and when you go to a further advanced level of geometry, then it covers, properties of space, and there's some other, things that are covered in geometry, properties of space, okay, and etc. So these size, shape and measurement, these are the very basics of geometry. Suppose you want to design a table, you want to design and construct a table. Now let's suppose that this table has two parts. This table that you are going to design or construct has two parts. Okay, you first divide it into two parts, and the first part is the top of the table, and the next one, the other part will be the legs of the table. Now when you cover the top of the table that you are going to design or and construct, so first you will choose a material, that what material you are going to use for this top of the table, whether it's iron, whether it's made of some other metal, or it's going to be the wooden table, or it's going to be plastic. Then you will decide, okay, now I have chosen the material, what shape I can give to the top of the table, whether it's going to be a round shaped, or it's going to be something flat, and in flat also it can be a rectangle, it can be a square, or like maybe of some mixture of this flat surface and this circular and the round one. So this is the shape. This was the shape that you decided. Now when you decide the shape, then the other point that comes in your mind is the size. What size are you going to make for this you'll choose for this top of the table? Then after material, then shape, then size. Then when you have decided this shape and size, then you will look for the measurement. That okay, if I have to make this top of the table as round, then what measurements I'll take. So according to that only you will cut off those materials, right, to make the top of the table. If it's going to be a round or a perfect circle or whatever, so according to that only you will take the measurements and you'll cut off that material to make the top of the table. Now then comes the number of legs of the table. Now when it comes for the legs of the table, again you'll decide whether it's going to be of same material, or some other material, whatever. and then again you will decide the shape, whether the shape of the legs will be, let's say that it's going to be of something of this shape, or it's going to be of something this shape, or it's going to be a round shaped and with the flat one mixed together. And then again you'll, in order to build this shape, you'll think of size, and when you have decided for the size, you'll go for the measurement. I mean, the similar approach that you will adopt here to construct this, to make this table, to design this table. So when you are done with all these, you know, requirements, I mean whatever you need to make this table, then you will start designing that table. Okay, then you physically start working on the table, and then you make your table. So if you see very clear, if you can see clearly, then here you are taking into account all those things, that is shape, the size, the measurements, and then after all these things you make your table, you physically design your table, and that's what, you know, geometry is. So after discussing introduction to geometry very briefly, now it's time to go a little deeper into geometry and understand some facts and concepts that we use in geometry. And we start with points. Now if I show you some dots, like maybe this, maybe a little bigger, little more bigger, or more bigger, or say more bigger. Okay, so these are representing some dots, and these dots are nothing else but points. Now points in geometry are actually, you know, exact position. They are exact position, they are exact position, they are exact location, the exact location, they are dots in geometry, these points. So points can be explained as an exact position, as an exact location, or say dots on any surface or in a space. Okay, on any surface, be a round surface, be a rectangular surface, or any plane surface, or in the space. That shows exact position or the exact location that we are talking about. Okay, or the dots. By the dots we mean that they don't have any size. They don't have any size. You can't say that these dots have some size, or we can't say that points have some size. They don't have size. They don't have size. Okay, they don't have size. And by that we mean that they don't have length, they don't have length, they don't have width, and they don't have depth. They don't have depth. They don't have all these three things. They simply represent a dot, exact dot, representing some exact position or exact location or whatever. And they don't have size, that is, they don't have length, they don't have width, and they don't have depth. Actually, it's really very difficult to give exact definition of line in geometry. Okay, it's very hard to give an exact definition. But a line, if let's say that you have 2 points. You have 2 points, and this is A and this is B. This is A and this is B. A and B. Now, if someone asks you to join these 2 points, if you join these 2 points, okay, so let's say you join these 2 points. Okay. Now, then again you take point C here and point D here. Now you join these 2 points, this one and this one. Maybe it's not looking accurate, a straight line, but I mean a straight, you know, pattern, but just assume that this is going in a straight fashion or a straight path. Then again you take another point, that is E, and here you take F. I'll say again that it might be not looking an exact straight path, but assume that this is straight path, it's going straight path. That is, all these points are aligned in a straight path. Okay, you again take some points, and it's G, and here it is H, and then again this goes on extending out at this end, and it goes on extending at this end. You again take some points like I and J. So again it is extending at this end, it's extending at this end. You again take some points, let's say K and L. So again this is extending at this end, and it's extending at this end. So this is what exactly a representation of line is. Line is nothing else but, it's a very infinitely thin. This line is actually infinitely thin, infinitely thin. Okay, this concept of line is actually infinitely thin, and it's a collection of points in a straight path, that is, it will go on extending at this end. Let me take some other color. It will go on extending here at this end, and it will go on extending at this end. That is, if you go on plotting some points here, then here, then here, then here, and then here, it will go on extending, and it will go on extending in a similar fashion at this end. That is, you cannot reach to any endpoints. You cannot have any endpoint at this side, you cannot have any endpoint at this side, and therefore if someone asks you that to draw a line between points A and B, you draw it in this way. So this is point A and this is point B. You draw it like this, A and B. Here also you had A and B, so you simply join or these points A and B, but line never has any two ends. That is, it will go on extending at this end, and it will go on extending at this end. So that's why it's represented with two arrows. These arrows represent that it's infinite, it will go to an infinite end, and at this side also it will go to an infinite end. There is no limit or boundary of these lines. Okay, so if we draw a line between these 2 points, that is by collecting these 2 points A, B, then you'll always represent them as A, B, that is these 2 points using which you have drawn your line, and you put a line above them like this. Okay, so to represent a line you use this mark, and that's what you have placed here. That is a line above these 2 points, and these 2 points are not the endpoints, they are simply the collection of points using which you have drawn your line, and they are not denoting any endpoints, and this is representation of line. So if someone says that what is this, asks you what is this, you will say that this is a line between 2 points A, B, and this is what is a representation of line. Again, A and B are not the endpoints, therefore there will be no endpoints of any line, okay, and line is always infinitely thin. You are just, here you can say that it's not infinitely thin, or it's not even looking thin, but just assume that think of it as an infinitely thin, a concept, and collection of points in a straight path, that you can place as many points you want, and it will go on extending and on both the ends. And again, you can write it as AB and put a mark of line above them, and you can also write it as BA, and you will place a line above them. These both are, same thing. There is no difference in between them. And even in this case, B and A are representing 2 points. They are not endpoints. And sometimes it's simply represented with some letters like L or M or N. So someone can say that this is line AB, someone can say that this is line BA, and someone can simply use a letter L, M, N without placing any, such marks. That is, you will not use these representations here or denotations here. You will not denote it using these symbols. Simply you'll use letters, that is L, M, N, and that's what a line is. Again, line is infinitely thin. It's collection of points in a straight path. It will go on extending at both the ends. There will be no endpoints, and to represent it or to denote it, you'll use this way or simple letters like L, M, N. So now we have discussed about line, and we learned that lines are infinitely thin and they are a collection of points in a straight path. So for them, it's important for you to know the line, then only you can understand line segment, and then only you can understand what's the difference between line and line segment. So in line, we saw that we can place as many points we want on a line, and the line is there is no limit of line at the either sides. That is, it can extend to an infinite end to at this side, and it can go at infinite end to at this end, at this side. Now if I take simply these 2 points, that is A and this point B, right, simply these 2 points, if someone asks you that, hey, this is a line you represented here, you told me that line has no 2 endpoints, that is, it has no 2 limits, it will go on either sides. But if I simply ask you that this is point A and this is point B, what is the length of this segment, or what is this segment? That's what a line segment is. Line has no endpoints either on this side or on this side. But if I take these 2 points, A and B, or even if I take these 2 points, L and suppose E, whatever, if I take these 2 points L and E, or I take point A and B, and if someone asks you that what's the length of this segment between AB, or what's the length of the segment L and E, that's what a line segment is. Line segment has 2 endpoints, whereas line has no 2 endpoints. Line segment always exists between 2 endpoints, and it's also infinitely thin. It is infinitely thin because it's a section being taken from a line, okay, but the main thing is it will have 2 endpoints. That is, it will be confined, or it will exist between 2 endpoints like A or B, A and B, or in this case L or E, or even you can take A or E, whatever, just you need 2 endpoints in between which in between those 2 points you can take that segment, and that is what line segment is. It has 2 endpoints, and therefore since it has 2 endpoints, therefore it will have a length. And the way in which we will represent a line segment, like in this case, you took line segment between points A and B, so you'll write A, you'll write point B, these are 2 endpoints, and you'll simply place a line segment above them. Since it has 2 ends, therefore you'll not have arrow as it was in the case of line. So this is AB, and similarly as it was in the case of line, where line AB was, you can write line AB as line BA also. Similarly, it can be BA, because here you again have two endpoints. But you'll not use any letter, like in line we use letter L, M and N. You cannot use any such letters here, L, M, N. So till now we have discussed about points, line, and then line segments. We are going to discuss about arrays. So in line you have no two endpoints, and to represent line will be like this. And in line segment you'll have two endpoints, and to represent them the way will be like this. And what's array? So in the case of array, you'll have one endpoint, and there will be no second endpoint. That is, you'll only have one endpoint on one side, but on the other side, just like a line, it will go on extending. That is, it will go infinitely. It will go to an infinite point. So if this is point A and this is point B, then point A is the end point. And what's ironic, it's ironic that though it's a starting point, but still we call it as a end point. Okay, why end point? Because in the case of line, we saw that line can extend, even it can go infinitely at this side and also on this side. But in this case, this array cannot extend beyond this point, and that is why it's an end point, though the array starts from here. Okay, it starts from here, and if you are drawing an array between these 2 points, then if A is a starting point, then B will not be the end point, because at this end, at this point B, at this side, this array will go on extending. Okay, it will go on to an infinite position, and to represent it, it will be the starting point A and another point, that is B, that is on this array, and you will simply put array over it. That is A, the starting point will be above A, and this arrow will be above B. Now, as it was in the case of line and line segment, where we saw that we can write line as line AB or line BA, both will be similar thing, same thing. In case of line segment, we can write it as line segment AB, and that will be equal to similar to line segment BA, but that will not be the case in array, because in array you have only one starting point or one end point, and there is no other end point. So you cannot write it as, this will not be similar to array BA. Why? Because B in this case is not the end point, but here in this case A is the end point or the starting point, and therefore we have placed the end point or starting point of array above A. Okay, so that is an important point to know. And if you want to think of array, you can think it of as, suppose this is sun. Okay, this is sun, and when sunlight comes out of it, so like if here we have our earth, so it's coming in the form of array. Why array? Because it can be clearly seen that it has a starting point, here, but it will go to an infinite, it will go infinitely. It will have no end. It will go to earth and will go to Mars and like that, because light can travel infinitely, right? So you can think of it as a ray, that is sunbeams or rays. Another can be if you have a torch, and when you light on the torch, then rays come out of it. rays come out of it. Suppose you have a bulb, this LED bulb or whatever, the light rays come out of it, right? So this is the starting point here, and this arrow represents that since light travels infinitely, so it will have no end at this point, and that's what a ray is. Now if you look at these two lines properly, then you can see that if at this position, like here, whatever distance you have here at this position, let me take with some different color. So the distance between these two lines, suppose it is, let's say A, okay, let's A is any arbitrary number, okay, so distance between these two lines at this position is A, and if you take at this position and if you measure it, it will again come as A. If you measure the distance between these two lines at this position, it will be A again, and if you again measure at this position, this will be A again. Now if you extend these lines, in this direction, okay, in this direction, since it is a line and line travels infinitely, so if you extend this also, so again if you go for the distance and if you measure the distance between these two lines, it will again come A, and you can continue this process of measuring the distance, towards this side to an infinite position. And similar thing you can do on this side. If you extend this line, okay, it's just a rough diagram of the line, though it may not appear straight because I'm drawing with my hand, okay, without any help of scales and all. And here also if you measure the distance, it will again come A. So the point is, such lines, as you can see here, L1 and L2, if the distance between these two lines always remains constant, okay, it always remains same, whether you measure the distance at this position or you measure at this position, or you can take up to the infinite position on this side and infinite position on this side, the distance between these two lines will always remain the same. And such lines are called non-intersecting lines or parallel lines. They are called non-intersecting lines or parallel lines. Since the distance between these two lines or such lines will always remain the same, therefore there is no point whatsoever that they will intersect at certain point. There is no way whatsoever. They will never intersect or they will never cross each other at any point, whether you take here or take here or take here. Such lines are called non-intersecting lines because they will not intersect or cross each other like this, okay, they will always remain parallel. So such lines are called non-intersecting lines or parallel lines. Now look at these lines. You have A, B, C and D. In A you have L1 and L2. If you can clearly see that these two lines, the position at this position, the distance between them is this much. At this position it's this much. At this position it's this much. At this position it's this much. And you can clearly see that as you're moving towards in this direction, the distance between these two lines is decreasing. And if I extend this line, it will finally intersect here at this position, right? If you extend this line also, and if you extend this one, So you can clearly see that it's intersecting at this position, and since its distance between these two lines was decreasing, therefore a point will come when there will be no distance between these two lines, and that will be the point of contact or the point of intersection of these two lines. And let's say that if this point is Q, so at this point Q, the distance between these two lines is 0, is nil. There is no distance between these two lines because they got intersected at this point. Therefore, since these lines are intersecting at this point, therefore these lines are intersecting lines. They are intersecting lines. Intersecting lines. So although in the original diagram they were not shown as intersecting, but you could clearly see that if you measure the distance between these two lines, then they are decreasing, and there will be a point when there will be no distance between these two lines, and that's the point of intersection. That's why they are non-parallel lines or intersecting lines. Similarly, in this case, if you extend this one, if you extend this line, and if you extend this line, again you can clearly see that they are intersecting here. Let's say it's Q. In this, it's already these lines have been shown as intersecting lines here. In this, if you extend these lines, this here, this one here, and you can see that they are, if you extend this one here, and this one here, so you can clearly see that it's intersecting here, and it's intersecting here. So let's say the intersection point is P, Q and R. So these three lines are intersecting. Okay, so L1, L2 and L3, these three lines are also intersecting lines. In this case you have only two intersecting lines. In this case you have only two intersecting lines. In this case you have three intersecting lines, and in this case also you have three intersecting lines. Why they are intersecting? Because the distance between these two lines will be 0 at this contact point, or the point of contact, or the intersection point. So it was all about parallel lines and intersecting lines. So we have a question here, and the question is, how many lines can pass through one given point? So suppose you have this one point, okay, and it's asking how many lines can pass through this point. So well, let's see. You can draw one line, you can draw another line. Okay, so line this, then this, then let's say another line, So it's very obvious that if you have any one given point and it's being asked that how many lines will pass through that point, the answer should be countless. You cannot count that. Why? Because you can draw as many lines as you want, because you have this one point and there can't be any limit of drawing number of lines through this point. And the next question is two given points. So let's say that you have 2 points, this point and this point. Now let's say this point P and this is Q. If you have to draw, the question is how many lines can you draw passing through these 2 points. Okay, the line should pass both these 2 points. The answer is you can draw only one line. There's only one line that is possible. There's only one line that is possible. Okay, and that's this one, right? Let's say this is L1. So if you have point P and Q or any 2 points, there's only one line possible through 2 given points. It can't be 3, it can't be 4, or it cannot be countless. Just one and only one.